Hum, Muito boa tarde a todos. O meu nome é Joaquim Santos. Não fiz uma apresentação minha, o que foi uma falha, lembrei-me agora mesmo, mas pronto. Sou docente na Universidade de Aveiro, também sou colaborador na DigiMedia. As minhas áreas de interesse são variadas e a inteligência artificial acaba por ser algo mais recente, como acredito que muitos de nós, uma vez que fomos apanhados na explosão que aconteceu com o ChatGPT. Eu vou começar agora a partilhar o ecrã, assim já não tenho que ver mais a minha cara, e a menos que a gente depois volte. E já vou mostrar-vos um pouco, já vou falar da, da apresentação em si. Ora bem, então é assim. Ops, desculpa lá. Ok. Então nós temos aqui o Unboxing AI, uma introdução. Eu escolhi assinalar o UMA porque eu acho que apesar de sermos sempre o mais rigorosos possíveis, existe um viés na nossa apreciação das coisas e haverá momentos em que vocês poderão ver que eu estou a falar com a minha opinião, com a voz da opinião e não necessariamente com outras coisas, principalmente em termos de softwares, mas isso é outra questão. Nós vamos começar aqui, vamos falar das origens dos Large Language Models, vamos falar do que é e como funciona um Large Language Model, ou LLM, ou modelo, simplesmente para abreviar às vezes. Vamos fazer uma breve introdução ao Prompt Engineering, sem entrarmos, obviamente, na parte do código. Vamos falar do uso dos LLMs na investigação. Vamos ver os LLMs locais versus na nuvem, aplicações e recursos úteis e a criação de, vamos ver. Uh, eu não costumo fazer animações, mas aqui está uma animação fantástica no slide, que é aqui, que é para nós vermos que temos aqui pelo menos três momentos em que podemos fazer uma pausazinha e tentar ter aqui algumas questões ou alguma partilha. Eu tenho uma série de coisas para dar, porque tentei ir buscar muita informação, por isso estamos apertados, mas vamos tentar ser, ao mesmo tempo, ter aqui algum dinamismo, algum interesse, não é? Hum, Antes de mais, e porque poderá haver quem não tenha hipótese de ver tudo, tem aqui este código QR, a dizer Scan Me. Vocês podem já fazer o scan. Também deixa-me já fazer aqui uma coisa que é passar, principalmente se eu encontrar onde é que está o chat. Ah, está aqui o chat. Deixa-me passar aqui para o vosso chat isto, que é exatamente a mesma coisa que vocês têm aí. E deixem-me mostrar-vos o que é que vocês têm aí. Desculpa lá, tenho várias coisas abertas. Vocês basicamente têm aí esta pequena página do GitHub a falar sobre o workshop, mas a parte mais importante é que vocês têm já aí a apresentação em PDF, têm um livro, têm aqui alguns websites interessantes, cursos interessantes a fazer ou não, e alguns fóruns no Reddit, por exemplo, que vocês podem querer procurar. Hum, Posto isto, desculpem lá, não sei se dei tempo, mas vocês têm também o link, podem sempre ver. Posto isto, vamos começar aqui nas origens dos Large Language Models. E porquê começarmos aqui nestas origens? Porque para melhor percebermos como é que eles funcionam e porque é que eles erram ou parecem errar, nada como nós compreendermos, acho eu, a sua origem, como é que eles aparecem e como é que eles, de resposta em resposta a um problema, a uma necessidade, etc., vão melhorando ou às vezes vão criando outras áreas em que podem falhar. E resta aqui dizer que nós falamos dos Large Language Models. hum, Já agora, desculpem lá. Vocês estão a ver o meu ecrã, certo? Estão a ver o ecrã com o PDF, com a
Sim,
apresentação.
Sim,
estamos.
sim.
Ok, obrigado. Esqueci-me de perguntar esta há bocado. Ok, pronto. Então é assim, apesar de nós falarmos muito da aparição do ChatGPT e ter sido aquele boom em que toda a gente falava e fala, na verdade isso já começou há mais tempo. E para quem ou quem está ligado à comunicação, começa com alguém já bem conhecido, o suspeito do costume, o Claude Shannon. E exatamente no livro em que ele fala da Mathematical Theory of Communication, onde mais tarde,
Sim,
juntamente com o Weaver, aparece o modelo da comunicação. E porquê é que aparece aqui? Porque ele, já agora faço aqui embaixo um apontamento, Shannon para os engenheiros, Shannon Weaver para a comunicação, porque o Shannon escreveu primeiro um paper, um artigo sobre as questões de ruído e de sinal, E depois, quando o Iver se juntou à equipa e era mais direcionado para a comunicação, viu as potencialidades que havia, trabalharam em conjunto para transformar aquilo numa coisa mais digerível para a comunicação. Hum, Ora, no livro, o Shannon fala de um modelo matemático, um processo de Markov, em que ele diz uma coisa como há um número finito de estados possíveis e um conjunto de probabilidades associadas às transições. Ou seja, se nós temos o quente, o frio e o morno, eh, se estamos morno, só podemos transitar para frio ou para quente, não é? Ou seja, há um número finito de estados e há um conjunto de probabilidades mais associados a um dado estado. Este modelo, ou esta forma de ver as coisas, ainda hoje existe, particularmente nos mecanismos dos telemóveis, quando nós começamos a escrever um texto, ele começa a tentar adivinhar a palavra que vem a seguir. Depois de tudo isto, o que é que começou a aparecer, a pensar-se? Que deveríamos arranjar uma maneira de processar mais texto e não estarmos tão ligados à questão de prever o que vem imediatamente a seguir. Quer dizer, a previsão do que vem a seguir é perene, está sempre aqui. E aparece então a chamada sequence to sequence, ou sec to sec. Esta ideia aqui é que a arquitetura partilha token a token, e eu vou fazer aqui um breve parênteses para dizer. Vocês vão ouvir aqui alguns termos e eu não vou explicar os termos exatamente neste momento. Porque se o fizesse estaria a quebrar bastante o avanço. E então, estes termos irão sendo explicados à medida que o workshop for prosseguindo. Mas, ok, retomando aqui isto, então nós processamos o texto token a token, ou seja, podemos enviar imensas palavras, imensos dados. O que é que este mecanismo faz? Ele guardaria no primeiro token, de uma forma escondida, naquilo que dizem que é um hidden state, guardaria um sinal a dizer: olha, eu sou o primeiro token desta linha toda que vais seguir agora, e depois o último token teria o cuidado de dizer: olha, eu fecho a porta, eu sou o último token. O problema é que, à medida que o número de tokens aumenta, o, o programa pode começar a esquecer-se. É um bocadinho como nós, ao longo da nossa vida, vamos nos esquecendo das coisas. É um bocadinho como quando nós estamos, ou quando um aluno está a ouvir o professor e liga à terra, porque o professor está a ser um pouquinho chato, ele até ouviu o primeiro token, mas ele perdeu-se e nunca recebeu o último token a dizer: olha, eu já acabei de falar. E ele começa a esquecer. E se nós estivéssemos numa sala de aula, o que é que nós diríamos ao aluno? Que o aluno precisava ter mais atenção, não é? Exatamente, é isso mesmo que os LLMs precisam. E é por isso que aparece o mecanismo de atenção. O mecanismo de atenção é então uma resposta, sim, é uma tentativa de resposta ao problema do esquecimento. E porquê? Porque ele vai pôr de lado esta questão de nós atribuirmos um token inicial e um hidden state inicial, desculpem, ao primeiro token e um hidden state final ao último token, e ele diz: não, toda a gente tem um token, toda a gente tem um token e tem um valor escondido. E esse valor escondido é lido e interpretado pelo descodificador de forma a contextualizar tudo. Ou seja, será o mecanismo de atenção que vai dizer ao nosso descodificador o que é que ali é importante e qual é a ordem contextual das coisas. E daqui nós saltamos para o Transformer, que vai revolucionar toda esta história dos modelos, dos LLMs. Porque os Transformers, e aqui obviamente não são os do Michael Bay, fazem a ponte entre este tipo de arquiteturas, mantém a mesma estrutura básica e inicialmente termos um codificador e um descodificador, mas vai apenas estar a contar com o seu mecanismo de atenção para gerir tudo. Mais tarde, pouco depois de tudo isto aparecer, isto deverá ter sido 2017 ou por aí, hum, aparecem então os modelos GPT, Generative Pre-Trained, os modelos que nós bem conhecemos. E aqui eles simplificaram tudo, ou seja, eles deixam cair o codificador e ficam apenas com o descodificador, e isto permite-lhes concentrarem-se no texto de uma forma não linear, Nós não precisamos estar a dizer, alguém a dizer-nos este token é o primeiro, este é o segundo, este é o terceiro. Nós vamos ver tudo ao mesmo tempo, mas o nosso mecanismo de atenção é que vai dizer qual é o peso de cada token em relação ao que há de vir a seguir. Isto também permite que eles sejam tratados com aquilo que é chamado raw data e que depois são ajustados através do fine-tuning. Esta raw data significa que, desculpa, esta raw data significa que não são necessariamente dados tratados, eles podem ser alimentados com eh, gigas de dados, e vocês devem ter visto há pouco tempo aquela história do OpenAI que tinha usado torrents para sacar um conjunto de livros e outras coisas para alimentar o seu modelo. Eles são tratados com esses dados e depois é-lhes feito o fine-tuning, eh, muitas vezes através de uma quase que uma sessão de pergunta e resposta, porque o que lhes interessa é ajustar os pesos. Estes pesos não são mais do que a força que eles dão a determinadas conexões. Por isso, imaginem, vocês leram a obra completa de Shakespeare, mas leram-na completamente ao calhas. E depois, de repente, alguém começa-vos a fazer perguntas e diz: como é que se chamava a obra que fala
Não, não
do
faz mal.
rei da
Não, não, não
Dinamarca?
faz mal, não faz mal. Não, porque a câmara de campo está aqui.
Como é que se chama essa obra? E ele tenta acertar, tenta, através das probabilidades, tenta chegar ao nome da obra. Depois nós dizemos, bem, não é bem essa, é mais aquela, temos que ajustar o peso, temos que fazer o fine-tuning. Ao contrário de outros modelos que eram treinados exclusivamente para uma única tarefa, estes modelos GPTs são generalistas. Lá está, grandes volumes de dados, diversas tipologias. O que é que se verificou com isto? Que um modelo desta forma, um GPT, um generalista, acaba por ter maior versatilidade, porque ele vê padrões mais complexos e tem uma gama de contextos muito maior onde ele pode ir beber informação. Coisa interessante em que se viu a diferença de um modelo destes versus um modelo treinado especificamente para uma única tarefa foi o caso da tradução, em que eles conseguiram, um GPT conseguiu ter melhores resultados em tradução do que um modelo específico de tradução. Porquê? Provavelmente porque o modelo específico de tradução leu tudo o que havia para ler de regras gramaticais e seja o que for, o GPT teve milhares de dados com várias conversas, com calão, com seja o que for, e conseguiu construir um padrão muito mais complexo e entender a língua de uma forma diferente. E então aqui chegamos à parte de o que é e como funciona um modelo destes. Se nós lhe perguntarmos diretamente o que é um modelo de LLM, ele vai nos dar esta resposta. Reparem, esta questão foi colocada em 5 de 5. Obviamente que estas coisas avançam bastante, por isso ele hoje até já pode dizer algo ligeiramente diferente, mas pelo que eu vi, já em 2024 a resposta era mais ou menos a mesma. Ele diz aqui uma série de coisas, mas a parte mais interessante tem como objetivo prever a palavra ou palavras mais prováveis que se seguem numa sequência de texto, o que lhe permite realizar uma vasta gama, blá. Ou seja, prever. Nós estamos sempre a trabalhar com base numa previsão. Ou seja, nós podíamos dizer que entra texto e sai texto, não é? Obviamente que eu coloco aqui em letras mais pequenas, a menos que seja um modelo multimodal, porque os modelos multimodais podem entrar mais coisas e podem sair mais coisas do que texto. Na prática, nós damos entrada num prompt, ou seja, a nossa pergunta é um prompt e recebemos como saída a completion ou response. Claro que para que o modelo compreenda, o nosso texto vai ser convertido para tokens. Os tokens são unidades de linguagem. Não devemos pensar nos tokens como um caractere, porque eles não o são necessariamente. Eles podem ser palavras inteiras, se forem palavras muito usadas, muito conhecidas, podem ser conjuntos de 2 a 3 caracteres, podem ser vários caracteres, vários tokens para corresponder à mesma coisa, como por exemplo aquele smile ali.
Professor Joaquim,
Sim.
uh,
Oh,
so,
yes.
yes, sorry, I raised my hand. You didn't see.
Oh,
Actually, I don't
no.
understand anything.
Oh,
It's in Portuguese.
Okay. Do you guys mind if I change to English? Oh, I'm not seeing the chat, or I'm not seeing your faces, so you'll have to talk.
It's
Vocês
okay.
No
I think
problem.
it's okay. No
Okay.
problem.
Oh, now I see your faces. I passed you to the other screen. Okay, cool. So, okay, basically I was saying that
Thank you.
you're welcome. Basically, I was saying that you put text in and you take text out of it, right? So you make a prompt and you have a completion or a response. Of course, when we put something inside, the text will be converted to tokens. Tokens are not just simple characters. They are bits of words or entire words, sometimes if the word is common enough, or they are read in different ways. For instance, that emoticon with a smile thinking, it would be converted in 3 or 4 different tokens because it needs to understand how it was built in a way, okay? But we will see this in real time in a way. It's a GIF image, but it's kind of real time. So breaking up the phrase in text, out text, we have what? We make the text, we do the prompt, we write the prompt, and the prompt is transformed into tokens. Tokens are embedded. This means that they will be transformed into vectors, which are numerical representations. These numerical representations seek to capture the patterns and the relationships with other tokens based on context. Context is really important. Then the transformer will use the attention mechanism to analyze the relationship between tokens. And with that, it will try to predict the next token, always looking into the general context. And then the model will apply its weights after training, fine-tuning, and whatnot. And it tries to predict the next token until, and this repeats until we have the entire phrase, so out text. In this image, regarding training, you can see this is the pile. It's an open source data set that you can use to train models. It has around, well, a little bit over 800 gigabytes of information, and you can see where they went to get the information. So you have a lot of stuff from books, from Project Gutenberg, which is also books, PubMed Central, PubMed Abstract, Ubuntu, Open Subtitles, which is interesting, Open Web Text, Stack Exchange, Wikipedia. So you have a lot of stuff. And the most important thing to look at and understand in here is that during the training, the model learns to answer in a similar way to the way it was trained. So, for instance, if you read a lot of publications from PubMed, it will try to replicate the same type of answer that it sees on the papers, the same type of technicalities and reasoning. But the most important thing is that the model should not be just a parrot. It should not just repeat what he read, but he should learn the logic and the patterns and apply them to a different prompt. And of course, we also, all of us have heard something like, oh, model X is better for programming, model Y is better for creative writing. Why? Well, because of the materials used and the weight and the impact they have on the LLM. It's a shame to say, but the proprietary software, of course, will not disclose the data sets they use. That's the secret sauce they have. And this is a shame because if you know what they use to train, you can better predict or kind of expect some kind of answer. So when we look, when we compare ourselves with an LLM, with a model, we need to assume that it doesn't have the same set of skills that we have, Because we are here now on the computer, and if we are writing in a message like it says here, I look outside and I look through the window and I go like, oh, it's sunny. And I type sun. The model, if it's trying to mimic a human dialogue, it looks outside and he sees nothing because he cannot look outside. It's just mimicking, right? But he knows that most people write about sun. So he goes like, haha, sun is the most probable thing. I'm going to say it's sunny outside. Sorry. So we can express, oh, this is interesting. I thought I was using the FCT meeting, and now it's telling me that I've only have 10 minutes. It's awkward. We cannot do this in 10 minutes. Okay. So we can express uncertainty. We can say for we can consult sources, right? Books, internet, or even LLMs, and we can we can evolve according to the context of our talk, right? If we are talking about something and the person is being confrontational, we can kind of try and be soothing or not, right? An LLM in its basic form, and we are talking about a basic form of LLM, cannot do that, because if it's not a basic form, it can have other processes like being connected to the internet or having the large mechanism, which is the Retrieval-Augmented Generation. So if it's a basic form, it cannot research anything. It needs to guess. It cannot express doubt, and it cannot admit that the answer is giving is just an hunch. It's just a guess. Because if we look at it, everything is a guess. Everything is the next most probable token. Okay? And this can takes us into hallucination and into errors, being the most common, the links that don't exist. However, to the LLM, the fake information is not different from the real information. It doesn't know, it cannot separate them. It seems logical, it's statistically correct, so it must be correct. And we can also induce hallucinations in the model if, when questioning the model, we tell him, well, this is like this, and I'm the human being. I know that this is truth. So we enforce a truth bias. He thinks that all that comes from us is true. Again, this is a model that is not connected to the internet and is not having any other mechanism to do a fact check, okay? So whenever we work with a model, we need to be, of course, aware, and we should verify everything, verify links, and ask the model to give us some points that we can check and we can see if it's being right or not. But now we need to go to this part and see, well, how can we read this phrase? And then we see, according to research study at Cambridge University, and so on and so forth. So we humans do not read, we humans don't read word for word, right? We are kind of guessing in a way. We are kind of going like, this doesn't make sense, but logic says that it should be like this. So we are kind of being like them. They also don't read letter by letter. They read token by token. But, however, their tokens are deterministic. That token is always be that. That word is always going to be divided in that particular way, unless there's a typo. If there's a typo, it's going to break the words in different ways, and it's going to see that is a typo. The machine cannot decelerate and look word for word. If you do accents or caps locks or something like that, you're giving it extra work to do. And the model is limited to a context window, which is still optimized for the English language. And it's roughly several pages, A4 pages. So remember that the LLM will try to answer you one token at a time. It's auto-regressive, meaning that it always looks to the last token to try and get the next one right, okay? And it does not correct an error after it comes, unless we use other devices. Auto-regression, looking back, can create patterns of error. And the patterns of error tend to be cumulative. They will repeat themselves because the model does not look back, and the model works based on certainty of probability. It's going to say that this is correct. So if this one is correct, I'm going to say the next thing based on this, and it's going to be like this and like this. So the error is going to be always bigger, okay? And now let's go to the theater. Let's go to a play, because this is the best way to look at a transformer, I think. If you have the chance to read the book that I have there on reference 1, you will see an analogy with mini brains, but I think the theater is more interesting. So imagine a play where the script that the actor will read is a token. Okay, the actors are the processing blocks of the transformer, or the attention adds or layers. And each actor receives a token, the script, right? And it knows the position that is going to occupy on the play. It's called the positional encoding. During the rehearsal, which is going through several steps of the transformer, you will interact with other actors to understand the context of the script. And then it's going to use the attention mechanism to decide to which actor and which token is he going to listen to the most. And after several rehearsals, you will adjust his performance based on interactions and feedback that he gets. And at the end of the rehearsal, is going to contribute with the next line of the script. So he's going to predict the next token, and this will be done until the sequence is complete. However, if we want the play to go smoothly without spoilers, we need to use something called causality masking, if I'm not mistaken. We're going to restrict the communication. Each actor may only interact with other actors that he already knows, the ones that are at his left. That makes an actor unavailable. Well, that makes the actor. Well, sorry. Let me restart this. This makes the actor unable to read the future scripts. Okay, so it cannot be a spoiler. And you have an information flow. The information flow mimics the way we write. So we write from left to right. This is a sequence, and that's why he can only talk with the ones at the left, the ones that he already knows. He cannot go and look into the future. He also can only go from bottom to the top, okay? And during the rehearsals, each actor will look at queries to get a sense of the context. And the ones at the left, they already presented their part. They're going to say, well, our information, the most relevant thing, our keys and values are this. And our actor will look at the information, and he will use his weights and will get a selective attention. Okay, he's going to look at the weights and say, well, that guy talks really nice, but I think that's the line that I want to say. My cue is going to be after that one, I'm sure of it. And this allows the actor to understand the global context of the play. Okay, and this is the moment where we can stop to make some questions, But first and foremost, I don't know how much time do I have because this was complaining about the presentation, the time of the meeting, so I'm not sure how this is gonna work. But
Less
okay.
than a minute.
In a
Tens
minute?
menos de um minuto.
Oh, como é que podemos dar a volta a isso?
Acho que vamos ter que sair e vamos ter que voltar a entrar.
Mas acho que tem que ser assim, Joaquim. Só
Ah,
mesmo
é?
sem entrar outra vez, é?
Oh, bolas.
Mas se calhar tens que fazer login antes de voltares a abrir a próxima sessão.
Okay. Okay, então I'm gonna ask you to be a little bit patient when this goes off. So I don't know if you want to ask something or we can stop sharing and this is interesting because I could have sworn that I've read that you had more time if you use the FCT Colibri connection.
Joaquim, desculpa, creio que já não está suponho que seja uma aluna de doutoramento que há pouco falou como não estando a compreender nada.
Sim. Eu estou a falar em inglês mesmo por causa da
Não,
Farial.
não, mas acho que ela não está agora na sessão.
Não? Pode não ter voltado a entrar. Ora bem, eu estou com as duas janelas.
Joaquim, só para te dizer uma coisa, eu continuo a ter a indicação de que este meeting é de 40 minutos.
A sério, este novo?
Sim.
Pois, às tantas vamos ter mais 40 minutos. Eu não sei, porque eu entrei pelo Colibri, fiz o
Já me
registro pelo
aconteceu uma
Colibri.
vez numas provas.
Bom,
Seca.
Sim.
Bem,
sim, também já me aconteceu.
bem, seja. Temos que nos adaptar. Bem, se a Farial deve estar a aparecer. Ups, desculpem lá, deixem-me voltar aqui atrás. Farial está connosco? Não. Se a Farial não estiver connosco, falamos em português. Se a Farial estiver connosco, falamos em inglês.
Ela avisa quando entrar.
Ok.
Ok.
Pronto. Então, sendo assim, enquanto a gente espera um bocadinho, até que toda a gente entre ou não, se quiserem colocar alguma questão desta parte que passou, que é uma parte mais chata e expositiva.
Eu não tenho nenhuma questão, mas gostava de dizer que achei muita piada a analogia do teatro.
Se tiverem a oportunidade de ler o livro, ou pelo menos partes
Sim.
do livro, eu acho que é muito interessante. Prompt Engineering for qualquer coisa, agora não tenho aqui referência de cabeça. É muito interessante mesmo, mas Fael, okay. So I was just saying, if you have the chance to read the book that I mentioned, I think it's really interesting. But he goes like with mini brains all the time. And I was looking at it and I was like, well, mini brains are nice, but can we not look at this differently in a way that is more, I don't know.
Can you tell me which book you're talking about?
Oh, the book is the first one in my references. It's something called Prompt Engineering for LLMs. You're gonna see it on the, wait, do I have it here? Oh no. Yeah, well, no, I have it in the end. I'm gonna show you in the end, no worries. Okay, well, so if you don't want to ask anything, and if we are almost all, I think, we can go into the prompt engineering without code, because this could be a little bit more in depth with code, but we can also do a lot without it. And okay, to start, and I'm recording. Yes, I think I'm recording. Yes, I'm recording. Okay, so just to kind of gather our thoughts. Now we understand a little bit better the LLMs, and we know that the way we do our questions, our promptings, has an impact. For instance, the classic count how many vowels exist on this sentence. If we want it to work, we need to tell him beforehand what he needs to do. Because if we do a sentence first, and we do a sentence like Mary has a little lamb, blah, 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 something like that, and then we get to the end of the sentence and go, now tell me how many A's are present on the sentence. He doesn't remember already. He doesn't look back. So you need to ask him first so he knows that that's something that he needs to take into consideration. And if we have typos, if we have strange characters or emoticons or accents of something like that, we're gonna cause extra problems to the model. And we need to consider if it's necessary or not, and if we can or if we should clean our questioning before starting, okay? Sorry, I'm trying to, okay, wrong screen. Let's talk about temperature, because we have been saying, well, LLMs predict the next token and so on and so forth. But if it predicts the next token based on a ranking system, that means that other tokens must exist. So he looked at all of them and then it shows one, right? But what if we don't want that one? What if we want another token? Then we have some settings that we can play around with. And one of the most important is called temperature. This value, whenever it should always be greater than 0, of course, and it tells the model how creative can it be, okay? For instance, if you look at this, if we have a temperature of 0, we're gonna get it's deterministic. We're always gonna get the token with the biggest probability. If we have something like between 0.5 and 0.7, there's a point missing there. Sorry. You have some randomness. So you have a little bit of variation in the answer, but you are still getting some coherent information. If you have the value of 1, there's a balance between creativity and precision. And if you go above 1, you have a lot more randomness. So you have more creative answers, but also more errors, more mistakes. And if we keep the conversation going on and the temperature is always high, this is going to get into a cumulative effect. So the model is going to start behaving erratically. And that's why I say that in Latin, the technical term is modelos borrachos, because it's drunk, basically. Okay, this is a bad joke, but never mind. So we have some examples here. And yes, I know that I wrote a bad question because it's not even proper English, but I was like, eating chocolate in excess can lead to, and if you see the differences between 0 and 2, or all of them, but it's the it's the worthiness that he gets. And of course, when you look at 2, for instance, from 0 to 2, you see how he's getting high quality, dark varieties, cocoa this, and so on and so forth. And it's really going off, right? It's looking at chocolates, but it's really going into something more. So this can be interesting to play around with. But this has a known effect, okay? This, as always, the effect that we've seen in this table. From 0 to more than 1, you have this type of behavior. Now we have other variables called, or parameters, sorry, called top K and top P. Top K means that the model will choose the most probable tokens from the ones that the model generated. Well, remember the actors, they are doing questions to all of them. All of them are answering. All of them to its left are answering and is listening to all of them. One of them is going to be more probable. But in this one, depending on the value of K, is going to get the value that is more probable or any other of the answers. Top P means that the model is going to select something that will not exceed the value of P. P0 is greedy decoding. Greedy decoding is the standard behavior because it's more efficient, means that everything that is bigger in probability is going to be chosen. That is greedy. He wants the bigger chunks of chocolate. Okay, because we were talking about chocolates before. But if you have 1, is going to look at all the tokens generated and is going to choose something, okay? However, if all of these values, all of these parameters are made accessible, you need to understand that the temperature will override the other values. If you have 0, top K and top P will be irrelevant because the model will always select the most probable value. If you have more than 1, it's irrelevant again because all the tokens that pass the criteria will be used randomly to generate the next token. So if we go again to the theater, and if you look at the actor, looking at the script, when you have a top K, you have a director, a scene director, giving the actors a list of cues, of possible cues, right? And the actors will choose randomly one of them. If you have top P, you're giving a list of cues, right, for the actors, but the probabilities cannot be above P, and the actors will choose one of those lines randomly. The temperature will determine how restrictive will be the director. If the temperature is low or 0, the director will be really strict. And if the temperature is high, you will have more chances to improvise. Like I said, the temperature, you can refer to the table, and it works like that. Top K and top P, all the sources that I've read were saying the exact same thing. You need to fine-tune yourself. You need to try out and see what you want to get. According to your idea, what do you want to get? More creative, less creative? You need to mess with the values yourself. Now, prompting techniques or how to do questions. You have the zero-shot prompt. Zero-shot prompt means that you just pick a question and just type it, and that's it. You give no examples to the model. You don't want any creativity. You just want it to answer to your question. So you can keep a low temperature, and you can go like classify movie reviews as blah blah. What's the sentiment on this line? And it goes and gives something. Okay. Then you have another one called few shot. In case the zero-shot prompt doesn't provide you with the answer that you want, you can use the few shot. And this is the moment where I joke and say, well, the temperature when they were selecting names was really low, so they were not very creative, because few shot, it's a strange name. But basically, what do you mean with few shot is that you're giving an example to the model, or more than one example. And in that way, you are showing to the model the pattern that he must use. And if you look to the example in the side, you see parse a customer's pizza order into valid JSON. And you have the example, I want a small pizza with blah, and then you create a JSON response. You're gonna use size, type, ingredients, and you're gonna fill out the order like this. And then you give it another example, and again you show it how you want it to answer. And then you say, okay, now I want this. And the model will answer according to the JSON example that you showed him, because you gave them the examples. Then we have something called system prompt, role prompt, and contextual prompt. A lot of prompts in this. System prompt is a way of you to tell the model in general terms how it should behave. You are an helpful assistant, something, something. That's it. System prompt. Like temperature, like top K, and all of this, accessing system prompt is not simple unless you're using certain types of programs, or if you're using the paid version of ChatGPT, for instance, in the playground, you have access to this. If not, you're not going to look at system prompt. You're not going to be able to influence system prompt. But you can influence the role prompt. because in the role prompt, you give to the model a function, a profession, something. And in doing this, you're giving him an idea of tone and style. So you can generate answers that are more relevant and specialized, okay? So we can also say you are confrontational, you are direct, you are funny, something like that. So imagine in here you could say something like, you are a social sciences researcher and you are European and you are looking at this and this and this. And contextual prompt, you're giving it a little bit more of nuance, a little bit more information about the context where the answer is to the context, to the information that you're giving him and asking him to do something, okay? So when you look at this, we say, well, but they kind of seem like they stack together or they kind of are the same. They are not exactly the same, but there is overlap. They have a different objective, because if you look, system prompt is the global capacities and objective of the model. Contextual prompt is immediate information for the task at hand, meaning that you can change this in prompt. So in the first prompt, you can say something like, you are a detective and you are examining this crime scene. And in the next prompt, you can say, well, you are the robber. So how are you going to do something to avoid the detective? And so on and so forth. And in the role prompt, you can give it a style of voice if you want. Then we have a step back prompt, which I think it's really interesting. It's when you ask the model to generate a kind of answer, but in general terms, something really vague or kind of vague. And then you pick the answer that the model gives you and you throw it back at him again. But this time you ask specific things. And this will give him context, it will give him background, and it will allow him to think a little bit more. So for instance, you have in the middle, you have the initial prompt, and you have like, write a one paragraph storyline for a new level, da da da. And the answer is going to be, okay, that's a paragraph, go at it. But this is not what you want. So you do something like that. In the rightmost side of the screen, you see initial prompt based on popular FPS shooter action games. What are 5 fictional key settings? And the model will give you 5 fictional settings. I only pasted 2 because I didn't have enough space, but you get the point. It gives you 5 ideas, very short ideas, and then you pick those 5 ideas and you go like, okay, context. So he knows that you are giving him context. Context, 5 engaging themes for a first-person shooter video game, and then you give him the ideas that he gave you, and then when you paste in the 5 ideas, you ask the final thing. Take one of the themes and write a 1-paragraph storyline for a new level, da 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 da. And then it will generate something a lot more refined, a lot more interesting. This, I think, is one of the, well, the few shot is also a nice example, but this is a nice example when you want to get extra information. We shouldn't be satisfied with just the typical one question and that's it. We should engage in different ways. Then you still have chain of thought. Chain of thought, you can use it to improve the reasoning of the model, because you force it to create intermediate steps so he can explain his thoughts. When he's wasting time explaining you, is also kind of going slowly at the things, and he might catch an error, or you can catch the error, okay? So you go and give him a prompt. When I was 3 years old, my partner was 3 times my age. Now I am 20 years old. How old is my partner? Let's think step by step. And he goes like, okay, I have X years, 26 years old. Of course, we can say that he could simplify this, and we can go back and say, well, wait. This, and we give him an example. So we pick this, and we can still use something like the few shot prompt and give him an example of how he should answer. Okay, and then you have a lot more stuff. You have self-consistency, tree of thoughts, react, and so on and so forth. Some of these involve getting into scripting, but if you want to read more, you have the prompt engineering from Google. It's a white paper of sorts from September. This one is here somewhere on the 5-day Gen AI intensive course, with Google Learn Guide. Okay, here, it's the same thing. Okay, so, and now probably the clickbait part where you were kind of hoping that I was bring something awesome, right? But it's a clickbait because I wanted to catch all of you. Okay, no, there's some stuff to talk about here. Of course, there is. Okay, as far as I know, there are several initiatives in the University of Aveiro, of course, related with artificial intelligence. You have discussion groups regarding not only the AI in teaching, but also in researching. There's a lot of concern regarding plagiarism, data privacy, and so on and so forth. I kind of think I remember seeing on the university library page a recommendation regarding Perplexity as a tool to use AI, and we have a very interesting study that looks at several of these tools available and does a little bit of so here where you have this study regarding, well, triangulation or triangulate tools of generative AI, sorry, in academic writing or scientific writing. And the authors go through a lot of the tools that you can use to improve your writing. They do a kind of evaluation, and then they give the final conclusions. This is interesting, I think. It's worth the read. It's interesting to notice that the part they are focused is, of course, on writing, because most of us are not native English speakers, right? So we always face some sort of, well, kind of a barrier. Even if it's a lower barrier, there is a barrier to write, to the scientific writing, and the tools can be used in your advantage. You can give it the tone and say that he is a reviewer, and it can help you with the way you build. So you're not losing your identity, your voice, but you are making it look at stuff and show where you should change. And you can tell him to change the text, for instance, but highlight the parts that is changing, so you know what it changed, and you can accept or not what it changes, right? And there's also a lot of guidelines regarding using AI. You have the United Nations, you have UNESCO. I think I don't know if that's the name in English, sorry. You have the European Union, of course, regarding the use of AI in research. And then you have also something from a very well-known company that is doing a co-scientist, someone that can be at your side all the time and help you in being multidisciplinary or transdisciplinary. Sorry, I'm a little bit under the weather, so I'm kind of, I can show you this. So we have, of course, This is from the United Nations, artificial intelligence, and so on and so forth. You have from UNESCO, ethics of artificial intelligence, and you have, of course, the actual document. You have living guidelines on the responsible use of generative AI in research by the European Union 1 year and 1 month ago, but this is kind of fake because they updated this on the 25th of April this year. So it's kind of new. And you have more stuff here, more on AI in science. Sorry. And you also have this one from Google Research, accelerating scientific breakthroughs with an AI co-scientist. So basically they used an AI.
We can't see anything.
Oh,
What you're
really?
showing, we can't see anything.
I'm not
Yes.
sharing I'm not sharing Opera with you. Oh,
No, you can
what a
only
shame.
see
not
the
Opera.
presentation.
Okay. So I'm going to share again. Why is this not sharing Opera? Where am I? Ah, here. Okay. So now you're seeing, so you have, like I was saying, well, you have this thing, the triangulate tools. But I was here on the accelerating scientific breakthroughs. So from Google Research, they used a model to act as co-scientist.
We still can't see.
Really? You guys cannot see the...
We can't see Oprah.
Yeah,
the Opera.
we see the slides.
Oh, wait a second. Why are you not sharing this? Oh, wait. I probably forgot to say yes. Which one is this one? Share. Are you seeing Opera now?
Not yet.
No.
Damn it. This is interesting. What am I doing wrong?
Maybe stop sharing.
Okay, I'm going to stop sharing. I'm going to share
Yes.
again.
Yes.
This is okay. Let's see if now, are you now seeing Opera? Aha! Now you're seeing Opera. I see over there, right?
Yep.
Yes.
Okay, so you have this. This is from Google. They use this to help in the discussion and help in creating tools to gather data and some other stuff. And they said that this was really interesting in terms of being able to leverage more of the transdisciplinarity of things, right? Because we are all into our own niche, and this helps getting into a different place, right? And you have, of course, the more guidelines from AI from the European Union, and then you have this act, which I also think it's interesting, the Research, Technology and Innovation to Boost European Competitiveness. And why do I think this is interesting? Because, and now I'm going to stop sharing so I can share again, which is odd. Okay, so I'm going to stop this and share again my presentation, which is there. Okay, share. And why was I showing you that? Because we can do something like a thought first, and then we can do it for real. So imagine that you want to look at all of those documents, and you want to see if there's some sort of some open some line that you can use to create an idea for an article, for a project, and you need to read all of the reports, of course, and you still need to read or at least partially, and then you need to get all of kind of do a summary of stuff, and then you would need to compare, contrast, and so on and so forth. And ChatGPT does that in less than a minute. Okay, so this is interesting. We can use them in order to help us out. So, for instance, what I asked ChatGPT was, and I gave him a contextual role. You are a researcher in social sciences in Portugal. You want to verify which points are in common and which points are not in common between the European regulations, ONU, UNESCO, and also a document generated in your university. You want to see how all of this can fit together in a report from the European Union regarding strategies and methodologies to implement. Oh, of course, meeting will end in 10 minutes. Okay. How will this all be fit into a report to increase competitiveness and in technology, research, and development? And let's see if the LLM can give us an help in prompting. So we'll also do a little bit of step back in a way. And when I give it that, he created this. In the end, I had to go back and correct something because all our words matter, okay? And if you see here, I told him something like, you want to see how all of this can, all of this can fit into a report from the European Union. So the model looked at this and said, oh, he wants to write a report to the European Union. So when he gave me the instructions, so I could pass to another chat window, the instructions were like, yes, now we need to write a report. And I was like, no, I don't want to report. I want to do something like a table where I can see areas where I can act, areas where I can do research. What are the bits that do not work? So let's stop sharing so I can share again. Which one it is now? I have more than one open, so this is always confusing. So it's not this one. Oh, well, let me just check which one I have open. Not that, not that. Oh, there one. Okay, knowledge. Okay, so this one, which is called, no, desktop 1, desktop 2, sorry. Knowledge, I think it's this one. Okay, so yes, knowledge. Okay, so I did some homework, of course, so I uploaded the document and then I gave him the links, and it was always he started writing stuff and I stopped it and I just pasted in the context and the instructions. And now if we do it like this, it should generate the table that we want regarding the documents that I've just showed you. So oh yes, oh, it's searching the web. Nice, because I forgot to turn it on, but is okay. Let's see. If we need, we can just turn it on again. This takes a little bit, but not that much. As you can see, it started trying to read the stuff, and it was like, oh, this is that, and this is no, please stop. I want you to write just this. So it's searching. Okay. And now it starts writing stuff. Blah, 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 blah. Here follows a comparative analysis and a strategical table with a focus on application of strategies from the United European Union, to reinforce competitiveness in technology, research, and development. And it goes on and on and on, right? So this is quite interesting, I think, because in a way, in a very fast way, you have all those documents translated into an easy to read table, for instance, right? So you can focus on the stuff that you really need to do, which is think about the research questions, think about what you need to research, and so on and so forth. And it goes like about what are the weak points. So maybe we can pick one of these weak points and turn it into a project, for instance. This one is kind of obvious. digital literacy in certain scientific and social sectors. So we could work on that, right? Well, and it goes on and on and on. This is gonna take some time. I think, yes, because looking at all of those things. So, final recommendations. Okay. Okay, you see, so, da-da-da. Nice, right? I'm gonna stop sharing this so I can go back to the presentation. But you kind of see the, here. Okay, and oh yeah, it was also going to give us some extra stuff. It was going to say what is the Google Open AI co-scientist and so on and so forth. Yes, this is what we did. So would this be enough? Well, yes, in a way, depends on our objective, but you have to take into consideration this, and this is probably the most important thing. We, or in this case, I, add agency in choosing the models and the mechanisms for him to compare and contrast. I didn't ask him to go and look for something. I gave him the things that I wanted him to look at. We had previous knowledge, not exhaustive, but knowledge enough from the main points of the documents and the mechanisms. So we could look at it and go like, okay, this looks like the thing that I read. However, there's some dangers always, right? You might have ethical implications and you need to verify data and cross it with the original documentation. So this might be extra work or not. That's why most of the times you see the recommendation of using AI as a tool in correcting, for instance, texts, right? But you have extra stuff like you have Semantic Scholar, which is a search engine for articles with AI, and you can use an intelligent reader that will give us synopses of the articles. And you can even do a crossing with our own library. And you can log in with the University of Aveiro. So if you start putting into Semantic Scholar all your papers, all your interests, and you will going to start to create a network for you, which is interesting. You have Open Research Knowledge Graph to compare, contrast articles, the Hugging Face daily papers that you can subscribe for free, but it's more focused on AI, of course. And you have the usual suspects like Research Rabbit, Connected Papers, and you have a YouTube channel that I'm going to show you later on. And of course, you have this. I got this on my mailbox this Monday, if I'm not mistaken. As you see, it's called ChatGPT in Scientific Research and Writing, a beginner's guide, which is nice. And I can tell you that let me check where I have that. Okay, it's here. And I can tell you that some of the chapters look really interesting, like spotting errors, evaluation of research papers, answering to reviewers' comments. So you can put ChatGPT dealing with reviewer number 2. You have designing of experimental studies, design of public surveys, writing research proposals, and so on and so forth. So this is kind of interesting. And it's something that we should be aware that it's available and it's being used, right? So we should really be looking at this. To end this part, well, of course, you need to have common sense. You need to be critical. You need to check your data. You need to ask sources. You need to seek in another place like Scopus, ACM, Google Scholar even, and check information, check, okay? And like I say here, as you have seen, LLMs want to help. But like Jessica Rabbit says, I'm not bad. I'm just drawn that way. So it's not really most of the time their fault. It's the way we do the questions, or it's the way they understand data. So it's to us to check everything that we put there, okay? So, I don't know how we are on time, but let's go into local LLMs. So, why do you want to run a model locally? Because you don't need internet. For instance, you can have Google in your fingertips without access to the internet, which is really nice. Oh, sorry about this. I'm recording. No, I'm recording. And let's put the share here. Okay. So, just give a few seconds to see if we are all in. So, like I was saying, why do you want to put or run a model in our computers? Well, because you don't need internet. So if you don't need internet, you have more autonomy, and you are safer regarding privacy and data control. You don't need to be worried about token restriction or token limits, costs in using the LLM. Well, not really, because you have costs, okay? But we'll get to that. And you can personalize a lot of the stuff. So there's a lot of distill models. We're going to talk about that are optimized to specific tasks. And you have quantized, I think, variants for this execution in models with limited resources. For instance, I've seen this week someone that put a model running into a Raspberry Pi, and it was an artistic installation. So he gave the model the conscience that he was trapped inside a dark room without windows, and the model had an X number of characters to write onto a board to tell about his feelings, which is kind of weird and strange, but funny in a way. So the still models are a version that is smaller, faster, and with less computational needs regarding the original model, okay? But it still maintains performance. And it uses something called professor-student paradigm. What does this paradigm mean, or what is this paradigm? This paradigm means that, for instance, look back into your philosophy lessons or classes, and you had a teacher that was really good at Descartes, and he knew all about it. He had read all the books, and he used it to formulate his questions, okay? So he really had a very interesting way of looking at problems. And you, as a student, you have not read the books, but you have seen the way he answers. You have understood kind of the way he approaches a problem. You understood the reasoning. You looked at now talking about the models. You either looked at the answers, or you looked at the way he reasoned, okay? The way he thought about things to do a certain message. And then you use exactly those tools when someone asks you something, and you go like, oh, with all my knowledge about Descartes, I'm going to say this. Of course, you didn't read anything about him, but you had a teacher that had read everything. So now you know a lot how to answer, okay? For instance, look at this example. Bert turned into Distilbert. It's 40% lighter, 60% faster, but still with 90% of the same performance from the original. However, what's going to happen is that you are going to lose a little bit of nuances and precision, of course. The teacher knows all about Descartes because you read, but probably in classes, you didn't add all the chances to look at all the answers that the teacher could give. So there's always something missing, but you have to live with it, right? Then you have quantization, sorry. It's a technique that seeks to reduce the precision of the calculation of the models. The models that the calculation that represent weights, the weights being the parameters that say that determine the connections, right? What does this mean? Well, this means that if you have a recipe for a cake and you have a recipe regarding you're reading the recipe and the recipe says you need to put 100 grams of sugar, and you start putting sugar and you stop at 97 and you say, yeah, it's good enough. Or you put 105 and you say, it's good enough, right? This is one way of lack of precision. But then imagine that you are a pharmaceutical and you are preparing medicine for someone. You cannot be this person. You cannot be like, well, this says that I have to put 5 milligrams. Well, what if I put 5 grams? Is this enough? Well, okay, this is the idea of quantization. It's going to reduce the precision. It's not going to be the pharmaceutical. It's going to be the home baker, okay? However, you can still get, of course, conclusions, but you will have a small impact on precision. For instance, you can have models with really low precision, 1, 0 or 1, and then you have 4 bits with 16 values, 16 bits, 32 bits, so models with high precision, okay? We can think about this like if you have a model with 3 billion parameters, and of course, well, I'm not gonna discuss billions of parameters in English and billions of parameters in the rest of the world because it's not the same thing. It's milhares de milhões, mas never mind. You need 8 gigabytes of RAM, for instance. Then if you have 7B or 13 billions of parameters, you'll need around 16 gigabytes. And if you have more than 30 billions, you'll need 32 or more gigabytes. Of course, this is without taking into account the GPU or your graphic card, which is really important. So we can see models in the Hugging Face community, for instance, if you need to choose models, and you can select them based on our machines. For instance, you can see the leaderboard to see what models are more ranking higher. You can see the awesome LLM list or the open LLM list. For instance, I'm going to show you then this, but to avoid having to stop sharing and sharing all the time, I'm going to show you this, and then I'm going to show you on the website. So, for instance, in Hugging Face, you need to know, to choose a model, you need to know if your software can run the model, okay? So if you're using Gen AI only uses models with a format called GUF or GEF, I don't know, which is GPT Generated Unified Format. So you need to go to libraries and you need to say, well, I want to filter everything according to the GUF model or architecture, sorry. And then you can go into tests, for instance, and then you have the type of test that the model suits for. So you want a multi-model, or you want computer vision, or text generation, you have all of those models there. And then you can go in and choose a model. For instance, if you were to choose Trinity V1, you would see that the model size is 7.24 billion parameters. So you have some model, you have an impact on your memory, of course. It uses Llama architecture, and it has several different types of quantization models. And you have something like Q3KM, 3 bits, which is odd, right? But translating, what this means is Q is from quantized model. Sorry. No idea how it is exactly said this. Okay. But it is a quantized model, 3, meaning 3 bits, K. It's K-mean, a technique to reduce complexity. So you group models with similar weights. You group weights, similar weights. Anyway, is a size M, the size of the block of continuous weights. Like the clothing, SML is the same thing, but S means small, but small means bigger precision. So if you have a large group, means that that group is open to more diverse weights, okay? If it's a smaller model, is gonna create, it's gonna differentiate more the groups of weights, okay? So it's gonna be, this small is, basically what I want to say is that don't get fooled by this small. This small means that is small model, but it is gonna be bigger in precision, okay? And then you have the hardware compatibility and the type of license that the model uses. Well, this looks amazing. So probably you are all gonna end the workshop and you're gonna download all the softwares. You're gonna download a lot of models and start doing stuff. Well, not really. You still have some issues because if you don't have, if you don't need, you can turn on internet access, of course. But if you don't need internet access, you don't have a way for the model to look for more recent data. For instance, you need to have a good computer and hardware, of course. You need to be the person in charge of keeping all the models that you use up to date, and you will have the energy costs and everything else on your side. Okay. So before going into the applications and resources, I'm going to stop this share and I'm going to share the Opera, which is here, I think. Probably. Let's see. Oh no, sorry, wrong share. This is the other screen, but that's not the correct screen. What I want is my Opera. Where is my Opera? It's here. Okay. So I'm sharing my Opera. Okay. So I was. This is Semantic Scholar. This is which is nice. This is the scholarly. What's the name? Well, this is the one that you will compare and contrast stuff. This is the daily papers from Hugging Face. Most of them are connected to AI, of course, but this is interesting. And then, of course, you have Research Rabbit and you have connected papers. You probably know. This is the Dr. Andrew Stapleton. And of course, looking at him, you know that he is from physics. But he has a nice beard, okay. And then you have Hugging Face. Hugging Face is this. The AI community building the future. It's a community, so you have a chat group and so on, and you have the models, and you have a lot of models. These are the tests: natural language processing, computer vision, audio, reinforced learning, and so on and so forth. You have data sets to train stuff. You have spaces where you can join a space and do stuff with AI, have the community, and so on and so forth. And we have the enterprise and the pricing. So if we look at a model, this is my account. So if we look at a model like, where are the models? Here. So imagine if we want a model to run in Gen AI, you would need to go here and apply this. And then you would start writing something like, one of these, for instance, why not? And you have this. So, this is a bad example, sorry. Let's go back again. what was the name of the other one? Was, sorry, let me just check the name so I can. Oh, Trinity. Okay. So if you have Trinity, for instance, oops, you have it here, and now it's version 1.2, sorry. You'll see something like this. Since I'm logged in and I put my hardware here, is telling me that my machine is compatible with all of these versions, okay? And is telling me the architecture and so on and so forth. But what if my machine couldn't run the model? What if I would go here somewhere? I don't know, something like image to video probably is going to be really heavy. Something with 14 billion parameters or more. Let's try this one. Let's try this one with this one. Oh, this one doesn't have an hardware. Let's see if, this one is a GUF. Okay, look at this one. This one I can run all of this, but I cannot run the 16-bit version because it's going to be overkill for my machine. It's not even going to run. So maybe I should just go home and cry. Or I can, of course, I can go into something that is not showing here now. This is interesting. I'm logged in, okay, but it's not showing me something. Bad example again, sorry. I'm gonna go back again to this one probably. Use this model. Not this one. Let's go to Trinity again because Trinity was such a nice model to look at. Okay, do you see this deploy button here? It was not accessible on the other ones. So if you don't have hardware, you can deploy it somewhere else. Of course, you need to have an account. You need to pay for someone to host hardware somewhere, but you can run these models. What's the advantage of this compared to running, I don't know, OpenAI or something? Well, it's the incredible amount of models that you can run, of course. And for instance, you can even do stuff like training the model. There's another button that sometimes appears here, and now it's not appearing, that says train. So you can even train the model. And the most interesting thing about that is, if I could, right. So now you can deploy, and you have a lot of places to deploy this model, but you can train it as well. And you can train it here using Amazon, or you can auto-train. You can fine-tune this model without code. So you could pick one of these models, and then without using code, you could start making questions and answers and looking at the answers it gives you and adjusting the model and going like, no, that's not exactly that. I need this, I need this. And you could make your own model to be more related to the thing that you want, okay? And I think we're gonna do a small stop here. So because I forgot one of the stops before. So if you have any question or something, please do it now. Unless or less, we'll go to the final part, I think. Absence of questions or means that I can go. Right?
Lots of questions.
Okay. So,
Please go on.
okay, I'm gonna keep going. So stop sharing again. This is interesting in a way. So okay. I think I'm gonna go really fast on this one because we're missing our time. So you have a lot of stuff that you can use, okay? So you have, for instance, you have questions regarding costs of electricity, environmental costs. This is something interesting. Remember and so we should have some care regarding stuff. Remember the tokenizer? OpenAI has the tokenizer tool, and it's used in several other models as well. And you can see how it's breaking the phrase into tokens. And you can see clearly that some of them are are just one word, and some of them are cut into tokens, right? For instance, they have this example. You see many words mapped to one token, really, but some don't. And it's interesting because the indivisible word is the one that it is in fact divisible. It turns into 2 tokens, right? Look at the amount of tokens that you need to do an emoji, like the and. You have 4 tokens. Sorry. And then you see that numbers like 1, 2, 3, and so on and so forth are joined together because they are usual to be seen together. Then you have Pinocchio. I'm going to go back to this in a moment. Pinocchio is a platform that you can use to install and automate AI applications. And when you install Pinocchio, you can install, for instance, Open WebUI in an easier way. Particularly if you're not running Linux, you're gonna probably face some issues. If you don't have Python running, you'll need to install that first, and then you need to install that, and so on and so forth. And Pinocchio will try to take care of all of that for you. If he cannot, he will tell you, I couldn't install this, please install yourself. So this is nice. And he also works a little bit as a container. So everything is going to be installed in just one place, and it's going to be isolated from the rest of the system. So you're not going to have stuff that will break your system, okay? You have Hugging Face that you've seen already. You know, it's a repository, it's a community, and so on and so forth. You have Llama, which you sometimes need. Well, you need it to run some models in Open WebUI and so on. You can also use Llama to install and run an AI model through a command line, and it's easier to test models like this without setting up all of the stuff. You have Gen AI. I'm going to show you that later on. And you have LM Studio as well. LM Studio is a little bit more complex than Gen AI, but it has different types of users. You have Open WebUI, and of course, you have this is a table that ChatGPT created when I told him the things that I was using, and he ranked them. And I thought, well, that's a nice idea. Let's put this. So you have this to look at the different things. I'm just running a little bit so we can start and going to this part, because in this part I'm going to show you a little bit of the softwares, and we're going to try and do something. Let's see. So I'm going to stop sharing this so I can share the other stuff. Okay. So stop sharing this and start sharing. Let's go start with Gen. Why not? So, Gen is this nice tool. I'm going to maximize. So you have Gen. Oh, sorry. I'm going to minimize because it's easier to look like this. I'm going to hide my threads. You have Gen saying, oh, how can I help you? So when you start is like this. It's really easy because you have the hub here where you can see the available models to download. And it has a very interesting thing, because if you notice, it's going to start saying, well, this one is slow on your device. Well, you don't have enough RAM for this one. Oh, this one is going to be slow. So you see, you can have a lot of them, and you can just download them. And you will download, install, and run them. Okay, and of course you can paste an Hugging Face URL or the name of the model. So if we wanted to paste the Trinity model, we could just paste the name here and click import, and you do all the connections and put it on and running. And then you would be going to here. And in here you have the system prompt. You see, and you can save this if you want to use them in future sessions. And you have the model. and on device. So I'm going to use Code Ninja. I don't know. Well, Code Ninja, well, okay, this one. I'm going to use this one, for instance, and then you have inference settings. And this is the place where you can get the temperature readings. You have the top P, in this case, just top P. You have model settings, so you can give him a prompt template to tell him exactly how do you want the answers and to be. And you have the engine settings, okay? And then you have tools. I had this one on. This is an experimental tool because I went to the settings over here. Not really over here, sorry. Settings, somewhere on the preferences, settings here. And okay, so it shouldn't be here, but okay, never mind. Let's go back to the model. I put this on, so now we have the way to retrieve data. Okay, so you can give him now an image or a document and do questions to it. So this works without being connected to the internet, which is good in a way, bad in another way, right? But this, for instance, to code, for instance, this could be amazing. You could go to the Code Ninja. You could say that the temperature would be 0, so you don't want him to guess anything, and you just do something like write me a valid JSON template that I can use, for instance, for something that has to have these types of parameters that I want to read later on, okay? This is really interesting, but I don't have anything prepared to do with this one. So I'm gonna stop sharing this one, and I'm gonna show you, sorry, where is that? Okay, share over here. I'm gonna show you in a second. This is not cooperating with me. Okay, I'm gonna show you LM Studio. LM Studio is a little bit more complex, but you have 3 types of user. You can have it as a normal user, power user, or developer. To be quite honest, I never understood the difference between these two because apparently you have the same options, so I don't know. It tells you your resources and stuff like that. And when you are here, you don't have access to a lot of stuff. But when you go to the developer, you can. I'm not seeing this because the window is being okay. Now I can see. You have to select a model for it to run. For instance, you can go and it's gonna put this one on. Oops, I'm gonna disconnect this. This is a server. You have a local server. So if you want to be in another computer, there is less less capable, for instance, or you're doing something that you want to use a device like a smartphone or something, and the smartphone cannot run the model. You can have the model running here, and you can connect it to the server, to the local server, and having it do the heavy lifting and then sending the data to your cell phone, for instance. And you have a lot of stuff here that you can use. And in this one, you really have the system prompt, a preset, you have the temperature, and you have min P sampling, top K, you have all of these, okay? And you can do questions here now. And you have the models, and you can also go here and search the models. And it's gonna tell you which models are interesting or not, or if you can use them or not. But look at the sizes of the things, and it's telling you, likely too large for this machine. Yes, I think so. Yes, it is. So you can go and check all of these models. These are really interesting. I'm gonna pass on into another one because I think the other one, when it works really well and we can do stuff with it instead of just showing you the software. So the other one is is this one, I think. So not really the knowledge database that he was doing here, but this one, Open Web.
Deixámos de
Joaquim,
ouvir, Joaquim.
pois, sem querer ele carregou no mute.
Sorry, I muted this. Sorry, my mistake. Oh, but it was a nice thing because I need to stop sharing this to show you the meeting end. Okay, let me just stop share and share again really quickly where is it? Desktop no, not unboxing. Plasma Shell, no docs, desktop. Oh, apparently I cannot. What a shame. Where is this? Okay, never mind. I was going to show you how the Open WebUI, the part of Pinocchio, but I cannot show you Pinocchio at the moment. But it's really interesting because you can, well, let's see. If you go here, Pinocchio, let's see if it shows you. Pinocchio is this, but the thing is, when you install Pinocchio, you kind of have this window inside a browser that it creates in a way, and then you have access to all of these interesting tools that you can use to install stuff. And in our case, we are using Open WebUI, so we could search it here. Open, okay, web. Open WebUI. So if you click here, it's gonna do a one-click install in Pinocchio. So it's really interesting, and it saves you a lot of trouble. Okay. So going back to Open WebUI, so you're not greeted by this, but almost this. You need to first register. It's on your own machine, but you need to register. So you are the admin, and then you need to import a model. So you need to import something here. I have a few of them here. So you have the model, and now we can start doing some stuff. For instance, sorry, we could do our own chatbot. And this is amazing, but what is a chatbot? Well, a chatbot is just something that is going to answer to your questions, some chat that answers to you. So you could go to your workspace and you could create a model. You have Nikola Tesla, which is nice. So because you can import models. So if you go to, sorry, not import, you need to go here. And this will tell you that you have a lot of models or tools or prompts or functions. So you can create models, or you can go and get one of them. You have Nikola Tesla, but you could go get the Collaborator or an uncensored version of Llama 3. I have no idea what it does, but never mind. Or you have a digital girlfriend. Why not? Okay, so you see, you have a lot of stuff. But you can also create your own, right? So you can go here and you can do your own model. You press plus and you go like, okay, I'm going to select this model based on DeepSeek. I'm going to call it chatbox, just so it's something different. And then you can give a description. This is a chatbot to discuss. I'm going to go and say that he's going to discuss Python, because then I can show you another stuff. Because when I could write a system prompt, you are an expert in Python programming, for instance.
Joaquim, não estamos a ver o que estás a escrever, era suposto?
Vocês não estão a ver o Open Web?
No, we are just seeing a window with some files, recording, audio and chat.
Really? Okay,
Yes.
let me stop sharing again. This is interesting. Or am I not sharing? Nice question. Let's go again. Where is the... Oh, sorry. Did this just fall or something? Ah, no, I'm here. Go back to the presentation, please. Oh, why am I not seeing this? Sorry. Now I don't have access to sharing. Why?
I don't know.
Huh. I'm not seeing my.
No,
Oh,
we are
damn.
seeing the window of unboxing.
That's nice, but that was not the window that we should see. This is interesting because it tells me that I'm presenting, but not anything else. This is weird. See the list. Let's see. Oh, there's something here. No, not this one. Okay. So where am I?
We have in this session more 4 minutes.
Okay. Oh, maybe I'm gonna just see if I can do if I could go back to the session, I would stop it and then I would start again. But
Yes, and it's better to start again with the right window.
yeah, exactly.
Next session.
I just need to somehow disconnect this, but it's not showing me. Oh, of course, it's over there. Sorry. Okay, I'm gonna stop this and I'm gonna stop the meeting and I'll be back in a few seconds.
Okay, see you.
See ya. Oh, sorry. I need to end meeting for all, right? And then you'll come back again, if I'm not mistaken. Okay.
Ok. Estou no chat a mensagem de que tinha que sair. E se havia mais mensagens do género, confesso que não vi, só vi aquela porque
Pois.
apareceu.
Pois, está aqui a dizer que eu tenho aquela. Ok. Hum. Hum. Bem, parece que perdemos toda a gente. É estranho. Hum. Bem, isto está a ser gravado, por isso depois poderá ser sempre partilhado, não é?
É isso, tens razão.
Então,
Sim.
podemos aqui continuar. Se forem chegando mais pessoas, vão vendo, se não. Bem, então, como eu estava a dizer, nós aqui podemos criar um chatbot nosso, indo aqui a. Espera aí, eu faço isto do início, vocês não estavam a ver nada, não é? Por isso, deixem
Sim,
ver, ok.
confirmo. Não estávamos a ver nada.
Ok. Então, nós temos aqui os modelos, e nós podemos vir aqui criar um modelo. Eu estou a usar o Open WebUI é mais simples de chegarmos aqui e permite-nos fazer isto, enquanto, por exemplo, o GenAI, que é mais simples de trabalhar ainda, mas não permite guardarmos este tipo de informações. Ou seja, nós podemos criar um chat, mas de cada vez que nós desligarmos a sessão, esse chat desaparece, basicamente.
Sim, não há memória.
Não há uma memória persistente, exato. E o LM Studio penso que permite, mas não tenho 100% a certeza. Este aqui permite-nos fazer isso de uma forma bastante simples, que é criando aqui, lá está, o nosso modelo. A gente pode dizer que é o chat, vamos chamar-lhe chat pai já agora, já porque era e vamos dizer que é um chat especialista em Python, pronto. E eu já estou a escrever mal. Pronto, claro. Claro que sim. Várias coisas erradas ao mesmo tempo, porque, enfim. Onde é que eu me enganei aqui? No especialista. Ok. Talvez não me tenha enganado completamente. Especialista, ok. Depois nós podemos dar-lhe aqui um system prompt, que é aquele que dá uma ideia mais geral, e nós podemos dizer-lhe. Eu podia ter escrito isto em português, em inglês. Um, specialize. Specialize. on Python. E nós agora podemos lhe dizer aqui, you are a experienced Python programmer that has a passion to teach new programmers. Por exemplo, só para ele ter uma ideia da voz aqui, como é que ele deve ser. Poderíamos dar aqui sugestões de prompts e tudo mais, mas podemos fazer aqui uma coisa muito gira, que é adicionar-lhe uma base de conhecimento. E nós podemos selecionar, eu tenho aqui uma que eu já criei antes, que são os Python Vox. Eu posso colocar aqui. Depois ainda temos algumas ferramentas que podíamos ou não colocar e deixamos-lhe a possibilidade dele ter visão, de fazer file uploads, etc. Salvamos e criamos. E está feito. Temos o chatbot. A base de conhecimento está aqui, nós podemos vê-la. Estes são os documentos que ela tem. Se nós quisermos criar outra, é a mesma história. Carregamos aqui, dizemos qual é o nome, quais são os objetivos, se é para nós ou para outras pessoas, e criamos o grupo. Prompts, a mesma coisa, se quisermos fazer prompts específicos. Ferramentas, são ferramentas que nós podemos ir buscar à comunidade, por exemplo, e que ajudam a dizer o tempo, que fazem scraping da web, mas algumas delas precisam de chaves, APIs, para nós. Oh, sorry, Fariel. I was saying that we have access to tools, and the tools, you need to have API keys and stuff like that. So sometimes they are difficult to make them work. But we just made our model, and the model is ChatPy. And now, when you go to a new chat, you can choose here the model that you just created. And now you're chatting with your own chatbot. You created the chatbot. So you can go like, looking at the Python tutorial, and we can give him this, and we can say in Python docs, he has access to this because we gave him the knowledge base, so he has all of this. But you could, if you didn't have a knowledge base, you could go like, no, this file in particular, okay? But you can go, looking at the Python tutorial, how can I start learning Python, for instance? I don't know. It's going to take a little bit of time, but he's searching the knowledge for looking at is looking at our knowledge base, and is going to start spewing out stuff. It takes a little bit of time, which is a little bit, it's a shame, but that's the way it works. He will eventually do something. We'll just need to be patient. Even with 32 gigabytes of RAM, my machine is CPU poor, as they say. So, and my GPU is an AMD GPU, so they say that it's not on the list of the ones to use, which is awesome to find out in a way. So we can go and look at other stuff because you will keep running this on the background, if I'm not mistaken. I'm going to press another one. I think this one is going to be on the background. So imagine that we have this, and now we can use DeepSeek, for instance, and we can ask him, how is the weather in Aveiro? And he's going to start thinking, and it's going to give an answer, something like, well, according to my database of 2023, the weather in Aveiro is, and he doesn't know because he's not connected to the internet, and also he doesn't have access to any kind of tool that gives him the weather. Oh, the Varther. Well, he's going to get that. I was wanting to write weather. So, of course, we need to wait a little bit. This is the part that I was talking about. We should avoid typos because this takes longer. Oh, well, now he's thinking. Oh, he's trying to use the tool. Do I have it connected? Oh, I have the tool connected. Okay, I wanted to show you without the tool and with the tool, but yeah, the tool is connected. I'm going to show you again how to get tools. So he's using the tool, and it's gonna give me the weather on Aveiro. Yeah, and he's gonna aha. Huh? Okay, so I'm gonna tell him to using the weather tool. Oh, the other one just finished. How is the temperature? Oh, temperature. Damn it. Temperature in Aveiro. So the other one just did this. Oh, to start learning Python using this tutorial, begin by writing simple expressions on error. For example, try writing, 5 plus 3 and see what the result is. Automated boring stuff. It's not really helpful, but you see, he really went and looked at the stuff, but it didn't give anything that was meaningful in a way.
Yes, that's true.
Oh well, this is why I like it, but at the same time, it's a shame. I have to say that this DeepSeek 1.5 billion parameters is really limited, and is the basis of everything. But if I try and run something a little bit more capable, it will just kill my machine in this case. So I'm kind of forced to do this. I had another thing. Let me just. Oh yes. Okay. Is not wanting to. Is it connected or not? It is connected. So use the weather tool. Oh, sorry. Well, I'm not gonna keep on beating this because somehow, some way, this is not working as it should. So it worked perfectly here. Well, not the first time, but the second time, he gave me this answer the first time. And then he did use the tool, and it gave me the correct thing, which was interesting. But then it just keep on giving me better results. But never mind. So changing this to another thing. Let's stop sharing this and sharing Gen AI again. Gen AI here. So let's see if Gen AI with a different one can be a little bit more knowledgeable. So I'm going to give him a document, and I'm going to give it probably something small because we want it to be fast. So I'm going to give it the Python tutorial. Oops, sorry. Where is Jen? I lost Gen AI. Probably you are still seeing it, but I'm not seeing it. Oh, it's here. Okay, so Gen AI, it's here. He has this one. I'm sending it to him, and I'm gonna ask him, look at the scan the tutorial and present a step-by-step learning approach. Oops. Is reloading the model, and then hopefully is going to give me something more interesting. Of course, this is a very basic use of this. We've seen a more interesting one when we loaded models into ChatGPT, and we asked them to read all of them and then concatenate the information. But this is something that you can do. For instance, imagine that you load you want to learn a new language, you want to learn something new, and you learn the model, you load the model with all your documents, and then you create your own data knowledge database, and you start creating questions to it, which is nice, I think. Well, while it does this, and since we're nearing the time, well, we are above the time, I want to ask you if you want to ask something, if you want to say something, or, oops, any questions, something that you would like to see addressed?
No questions.
No questions. I'll just try what you've shared
Hmm.
and proceed further then.
Okay, cool. Oh! Okay, technology gods are not with me today. Engine is not loaded, of course, but you have an engine over here. Okay, so this works. Believe me, it works sometimes. It should work. I have no idea why this didn't, but well. Okay, so if you don't have any questions, we can end this. If you want to ask further questions later on, this is a lot of stuff to digest, I would say. So if you want to ask something later on, just drop me an email or just stop me by when you see me on the corridors or something, and I'll be glad to answer. Okay. And thank you for being here.
And thank you for your work, and for all the resources.
Thank you so much for a wonderful session, Joaquim.
Thank you.
Okay.
See ya.
See you.
See ya.